At 2050 Universal Time on June 30th, the sun reached across 93 million miles and switched off the radio over North America. It was an X-class flare, the highest category we have a name for, and it triggered a strong, continent-wide radio blackout in a matter of minutes. But here's the part almost nobody is emphasizing. The region that fired it is not the biggest, most dangerous sunspot facing Earth right now. That one is more than twice the size, aimed straight at us, and it has stayed terrifyingly quiet. Over the next hour, I am going to show you the flare, the comet that fell into the sun right before it, and the earthquake that struck in between. Stay with me, because the worst may be yet to come. Before we start, drop a comment and tell me, coincidence or connection? Hit subscribe so you are here, the moment that giant sunspot finally fires. Now let's get into it. At roughly 2050 Universal Time on June 30th, 2026, the sun reached across 93 million miles of empty space and quietly switched off part of the radio spectrum over North America. Nobody heard a bang. Nobody saw a flash unless they were staring at the right instrument at the right second. But high-frequency radio operators from the Pacific to the East Coast watched their signals sink into static, and the reason was a single, violent event on the surface of a star. A sunspot region had just fired an X-class solar flare, and its light had crossed the solar system in 8 minutes and 20 seconds to slam into the top of our atmosphere. The flare was rated X1.1. That letter X is the top tier of the scale we use to measure solar flares, and I want you to hold on to what that letter really means, because the whole story rides on it. Flares are sorted into classes named B, C, M, and X, and each step up that ladder is a tenfold jump in raw X-ray energy. A C-class flare is 10 times stronger than a B, an M is 10 times stronger than a C, and an X is 10 times stronger than an M. So when the sun throws an X flare, it is operating in the highest category we have a name for, and this one carried the energy of something on the order of 10 to the 25th joules. That is a number with 25 zeros after it. It is more energy than human civilization has generated in its entire history, released from one spot on the sun in a matter of minutes. When that burst of X-rays and extreme ultraviolet light hit the day side of Earth, it did what strong flares always do. It slammed into the ionosphere, the electrically charged upper layer of our atmosphere, and it flooded it with extra energy. Long-distance radio depends on that layer like a mirror. A shortwave signal leaves a transmitter, bounces off the ionosphere, and comes back down over the horizon, which is how a single station can be heard across an ocean. But when a flare suddenly overcharges that mirror, the lower edge of the ionosphere thickens and starts absorbing the very signals it is supposed to reflect. The mirror turns into a sponge, and on June 30th, that sponge spread out directly beneath the sun's position, which at that moment sat over the Pacific between Hawaii and California, and the shadow of degraded radio fanned out across the whole continent. Space weather forecasters have a scale for that too, and they logged this one as an R3. On the radio blackout scale, R3 is labeled strong, and it means wide area high-frequency radio loss for about an hour on the sunlit side of Earth, along with navigation and satellite communication problems. Pilots on transoceanic routes, mariners, ham operators, emergency services that lean on high-frequency backups, all of them felt the sun lean on their equipment at the same time. This is not the end of the world. Planes did not fall out of the sky, but it is the sun physically reaching into our infrastructure and pressing down, and it is the kind of thing that used to happen to a civilization that barely noticed, and now happens to one wired together by signals that bounce off the sky. Here is the part that should make the hair on your arm stand up, though. This X1.1 flare, this strong radio blackout, this continent-wide burst of interference was not the main event. it was the warning shot, because the region that fired it is not even the biggest, angriest, most dangerous sunspot currently turned toward Earth. There is another one, larger, more complex, sitting almost perfectly at the center of the sun's disk, aimed straight down the barrel at us. And as of right now, it has stayed strangely, ominously quiet. The flare that blacked out North America came from the smaller of the two. And that is the thread I need you to hold on to for the next hour. Because everything we are about to walk through, the storms, the comet, and yes, the earthquake, all of it circles back to one question. If this was the opening act, what happens when the big one finally lets go? To understand why forecasters are watching that quiet giant so closely, you have to rewind the tape. Because the sun did not go from calm to X-flare in an instant. It spent more than a week loading the spring. For about 9 days before that X-flare, the sun had been doing something subtle that only the people who watch it every day would notice. The background level of X-rays streaming off it had been slowly, steadily climbing. Most of the time, our star sits in what we call the B-class background, a low crackle of energy that barely registers. But over those 9 days, the baseline crept up into the C-class range and stayed there, which is already an order of magnitude hotter than the quiet sun. Think of it like a pot on a stove, where the burner keeps getting nudged higher. The water is not boiling yet, but the surface has started to shiver, and anyone standing in the kitchen can feel that something is coming. Then, about 8 hours before the X-flare, the sun cleared its throat properly. At around 12:57 Universal Time, on June 30th, a long-duration M5.8 flare erupted from a region over on the western half of the sun's face. That M5.8 was not as intense at its peak as the X-flare that followed, but it made up for it in stamina. It was a long, drawn-out burn rather than a quick stab, and long-duration flares are exactly the kind that tend to hurl material off the sun. It threw enough of a punch to cause a moderate R2-level radio blackout over Europe and the Atlantic, and it told forecasters that the regions rotating across the sun were not just posturing, they were loaded. Between that M5.8 and the X-flare later that night, the sun never really settled down. One region in particular went into a near-continuous rhythm of low-grade flaring, firing off M-class flare after M-class flare, roughly a dozen of them in the M1 to M2.6 range across the span of a single day. None of those individually would make the news, but stacked together, one after another, they kept the ionosphere permanently charged, they held that background level elevated, and they kept a minor R1 radio blackout simmering almost the whole time. The sun was not flaring and then resting. It was flaring, and then flaring again before it had finished cooling down. It was, in the plainest possible terms, cooking. And this is all happening at a moment when the sun, by the calendar, should be starting to calm down. We are in what scientists call solar cycle 25, the current 11-year rhythm of the sun's activity, and we are past its peak, sliding down the back half of the cycle. On paper, our star should be winding toward quiet. Instead, it has spent this cycle overperforming the forecasts, throwing more big flares in its supposed decline than many scientists predicted for it even at its height, and weeks like this one are exactly why. When a single region keeps up that continuous drumbeat of M flares, the effect on us is not dramatic enough to make the evening news, but it is relentless. Every one of those flares nudges the ionosphere again before it has fully relaxed, so the radio degradation never completely clears. The navigation systems that lean on satellite signals carry a low hum of extra error, and the entire day side of the planet sits under a sky that is subtly, persistently charged. It is the difference between a single thunderclap and a storm that grumbles on the horizon for a day and a half without ever quite passing. And a sun that grumbles like that is a sun with more left to say, All of that activity traces back to two enormous sunspot groups that were facing Earth at the same time, and you need to meet both of them, because they are the two main characters in this story. Astronomers label sunspot regions with numbers, and these two were neighbors on the solar disk. The first, the one doing all the loud work, had grown at a frightening pace over just a few days into a big, magnetically twisted knot. It covered an area around 700 millionths of the sun's visible hemisphere. It held more than 24 individual dark cores, and it carried the magnetic classification that flare forecasters fear the most. This was the region that fired the X-1.1 and kept up the machine gun rhythm of M flares. It was fast-growing, tightly wound, and clearly unstable. The magnetic classification I just mentioned deserves a moment, because it is the single best predictor we have of whether a sunspot is about to explode. When scientists map the magnetic field of a sunspot, they are looking for how tangled it is. A simple spot has one clean north pole and one clean south pole, like an ordinary bar magnet, and it mostly just sits there. But the most dangerous regions get classified as beta gamma delta, which is a technical way of saying the magnetic field has been braided into a knot, so tight that opposite polarities are crammed right up against each other inside a single dark core. That crowding stores enormous magnetic tension, like a spring wound past the point of comfort, and when those opposing fields finally snap and reconnect, the energy comes out as a flare. Both of the big regions facing Earth on June 30th were rated beta gamma delta. Two loaded springs, side by side, both pointed at us. And now, the second character, which is the reason this video exists. Because the region that fired the X-flare was not the biggest one on the sun. The biggest one had, at that point, done almost nothing. This second region was enormous, covering an area of roughly 1,450 millionths of the solar hemisphere, more than twice the size of its already dangerous neighbor. It held nearly 30 dark cores. It carried that same volatile beta-gamma-delta magnetic classification. And crucially, it sat almost dead center on the sun's disk, which means it was aimed as directly at Earth as it is geometrically possible to be. If the smaller region was a loaded gun fired off to the side, this one was a loaded gun pressed against the glass, staring straight at the camera. For all of that menace, though, this giant had refused to fire. It sat there through the M flares, through the X flare, through the whole 9-day build, producing broad, sprawling loops of magnetic field that arced high above its surface and reached out across its surroundings, connecting to everything around it. To the people who watch the sun, that behavior reads one specific way. It looks like a region that is holding back an enormous reservoir of pent-up energy and plasma, a region that has not released its tension because it is still accumulating it. And a large, complex Delta-class region aimed straight at Earth that is quietly storing energy instead of spending it is precisely the setup that precedes a truly major flare, the kind that could rate X5 or higher, or a monstrous long-duration burn that pours energy at us for hours. The worst is yet to come, and it has a name and a number, and it has not moved yet. Keep that giant in the back of your mind, because we are going to come back to it, and when we do, the timing is going to matter more than you think. But first, we have to talk about the thing that showed up in front of these sunspots without any warning at all, and vanished. Just before the sun began its serious flaring, something slipped into the frame of the cameras we used to watch it, and then it was gone. We have instruments called coronagraphs, which work by using a solid disk to blot out the blinding face of the sun, so we can see the faint outer atmosphere and anything passing through it. And on those images, in the hours leading up to the big flares, a small comet appeared out of nowhere, streaking inward toward the sun, with no advance notice whatsoever. Then, as millions of people would later see in the replay, it simply dimmed, smeared, and vanished. It fell into the sun and it did not come back out. Comets like that are called Sungrazers, and their story is genuinely one of the more haunting things in the solar system. A Sungrazer is a comet on an orbit that carries it terrifyingly close to the sun, sometimes skimming just above the surface, through temperatures and radiation that no ball of ice and dust can survive. Most of them are small. They are often discovered only in the final hours of their lives when they blunder into a coronagraph's view, and most of them do exactly what this one did. They dive in, they boil away, and they are gone forever, vaporized into a wisp of gas and charged particles. This particular comet gave no warning, arrived on the coronagraph, and evaporated near the same line of sight as those two loaded sunspot groups. And then, within hours, the flares came. To give you a sense of how routine this grim little drama actually is, consider that a single sun-watching spacecraft, launched back in the 1990s to stare at the sun day and night, has by itself discovered many thousands of these sun-grazing comets, most of them caught in the very act of dying. A great number of them belong to a single family, the shattered fragments of one enormous comet that broke apart on its own close pass centuries or millennia ago, and its scattered children still fall into the sun one after another, generation after generation, like moths that never learn. One famous member of that family actually survived its plunge back in 2011, whipping around the sun and staggering back out against all odds, and its survival made headlines around the world, precisely because it was the rare exception. The rule is disappearance. So when this particular small comet showed up unannounced and boiled away in front of our two loaded sunspots, it was doing the single most ordinary thing a sungrazer can do. What was not ordinary was the audience it happened to have. A pair of tangled regions sitting right on the edge of eruption, and a planet full of people primed to read the death of a comet as a sign. Now, a theory has been circulating online, and it is a genuinely seductive one. So, let me lay it out the way its believers do, before we test it. The claim goes like this: the comet did not just happen to die in front of those sunspots, it triggered them. As the comet vaporized, it turned into plasma, into electrically charged particles, and comets are known to carry their own magnetic fields, sometimes far stronger in their immediate surroundings than the ordinary solar wind. So the argument is that this dying comet, wrapped in its own magnetic bubble, dumped a surge of charged particles into the magnetic architecture of the sun, that those particles funneled down the magnetic field lines straight into the sunspots, which are themselves giant magnetic vortices, and that this surge was the spark that destabilized them and set off the flares. The comet lined up with the sunspots, the theory says, and then the sun exploded. Not a coincidence, a cause. I want to be fair to that idea because it is not stupid, and it is built on things that are actually true. Comets really do vaporize into plasma, not just gas and dust. The universe really is dominated by plasma, that fourth state of matter, where particles are stripped of their electrons and become electrically charged. Comets really can carry enhanced magnetic fields. And electromagnetism really is, particle for particle, an almost unimaginably stronger force than gravity. So the ingredients the theory points to are real. The question is whether you can actually cook this particular meal with them, and here the data pushes back, hard. Start with how often sun-grazing comets die at the sun. It is not rare. Our sun-watching spacecraft have recorded thousands of sungrazers plunging in and vaporizing over the years, and the overwhelming majority of them are followed by exactly nothing. No flare, no eruption, no response from the sun at all. If dying comets reliably triggered flares, our records would be wall to wall with the pattern, and they simply are not. Then look at the sunspots themselves. These were not calm, stable regions minding their own business until a comet poked them. They were already among the most volatile magnetic configurations the Sun produces. Beta-gamma-delta monsters that had been building tension for over a week and were firing flares on their own schedule before, during, and after the comet's arrival. They did not need a spark. They were a box of matches sitting in the sun, and they were going to light with or without a comet in the frame. And then there is the brutal arithmetic of energy, which is where almost every one of these seductive theories goes to die. An X-class flare releases something like 10 to the 25th joules. A small sun-grazing comet, even a magnetically active one, carries a field, and a mass so tiny by comparison that the energy it could conceivably inject is a rounding error against a rounding error. Asking that comet to trigger the flare is like claiming a single lit match tossed at the base of an erupting volcano is what set off the eruption. The volcano was already going. The scale does not work. As for the comet lining up with the sunspots, that alignment is a trick of perspective. We are looking at a flat image of a three-dimensional scene, and a comet falling in from one direction can appear to pass right in front of a sunspot that is actually millions of miles away from it, the same way you can hold your thumb up and blot out the moon. It is line of sight, not contact. There is a smaller cousin to this idea worth clearing away while we are here, because the timing invited it. This all unfolded during a full moon, and a claim rides along that the full moon floods the Earth with extra energy, reflecting not just visible light, but ultraviolet, extreme ultraviolet, even gamma rays, charging up the atmosphere and priming the planet for big events. The kernel of truth is thin but real. The full moon does slightly increase the moon's contribution to the tides in the ocean and in the solid rock of the Earth, and tidal stress is one of the very few genuinely documented, if very small, nudges on earthquake faults. But the version where moonlight is charging our ionosphere with reflected gamma rays is wildly overstated. The energy in moonlight arriving at Earth is trivial next to the direct output of the sun, and it is not rewiring our upper atmosphere. So we hold the small true thing, the tiny tidal nudge, and we let the rest go. So the honest verdict on the comet is this. It is a genuinely eerie image. A ball of ice falling into a star and vanishing right before that star erupts. And I understand completely why people watched it and felt they were seeing cause and effect. But the sun was already primed. Dying comets almost never trigger anything, and the energy budget forbids it. It is a spectacular coincidence, not a smoking gun. And I would be comfortable leaving it there, filed under haunting but unrelated, if it were not for what happened next. Because in the gap between those two flares, while the sun was mid-tantrum, the ground on the far side of the planet tore open. And it did not tear open just anywhere. While the sun was firing, the Earth answered. At around 1945, Universal Time, on June 30th, a magnitude 6.0 earthquake struck in the Gulf of California, off the coast of Baja California, Mexico, just south of the United States. And I need you to sit with the timing for a second, because it is the detail that launched this entire investigation. The long M 5.8 flare had peaked at around 12:57 Universal Time. The X 1.1 flare would peak at around 2050. And the earthquake struck at 1945, almost exactly in the gap between the two, as if the planet were keeping time with the star. The earthquake itself, taken purely on its own terms, was not a monster. A magnitude 6 is a serious quake, but it is not a disaster on the scale of the ones we have been tracking, and this one happened offshore in the Gulf, about 10 kilometers below the seafloor. Its strongest shaking sat right over the epicenter out in the water. It registered as no more than light shaking in the nearest towns like Cabo San Lucas and the coastal cities of Sinaloa. And because of the kind of fault motion involved, it generated no tsunami. It was followed within hours by a magnitude 5.3 and a magnitude 4.5 in the same area, the ordinary aftershock chatter you would expect. If you lived nearby, you felt a jolt and some rolling, and then it was over. On paper, this is a forgettable quake. The reason it is not forgettable is where it happened, and to see that, you have to understand what the Gulf of California actually is. That long, narrow sea between the Baja Peninsula and mainland Mexico is not just a scenic body of water. It is a plate boundary that is actively tearing itself apart. The same boundary between the Pacific Plate and the North American Plate that we know farther north by a far more famous name runs straight down into this gulf. Up in California, that boundary is the San Andreas Fault, grinding sideways in what we call strike-slip motion. As it heads south, it breaks up into a chain of strike-slip faults linked by short segments of seafloor spreading, and those spreading segments are literally prying the Gulf open, millimeter by millimeter, year by year. So this magnitude 6 did not happen in some random patch of ocean. It happened at the southern hinge of the exact same fault system that runs north through California, and the fault motion, that sideways strike-slip grinding, was the same style of motion the San Andreas makes. The people who study this looked at the fault mechanics of the quake and confirmed it was a strike-slip event, the crust on one side sliding horizontally past the other, with just a hint of pulling apart mixed in. That matters because it tells you this was the boundary doing its characteristic thing, releasing a little of the strain that builds as the Pacific Plate drags northwest against North America. And it tells you the energy released here was loaded onto the southern end of a system, whose northern end is the most anxiously watched fault line in the United States. When one segment of a great fault system slips, it does not just relieve stress. It can transfer stress, quietly reloading the segments next door. And the segment next door, in this case, is the road to California. But the story does not start in the Gulf of California. It starts farther south and days earlier, and this is where the pattern that has so many people uneasy comes into focus. 6 days before this quake, on June 24th, the ground had already torn open catastrophically in Venezuela. 2 earthquakes, a magnitude 7.2 and a magnitude 7.5, struck about 39 seconds apart near the capital, Caracas, the second and fourth strongest earthquakes in the country's recorded history, arriving in the same terrible minute. Nearly 800 buildings came down. The human toll has climbed past 2,000 dead, with tens of thousands still missing beneath the rubble in what is quietly becoming one of the worst natural disasters of this century. A catastrophe that has received a fraction of the coverage it deserves. We devoted our entire last investigation to what happened in Caracas and why so many buildings fell the same way. And if you want the full anatomy of that tragedy, it is waiting for you. For our purposes tonight, Venezuela is the starting pistol. Because ever since it happened, the significant seismic activity has seemed to march northward, up the spine of the Americas. From Venezuela to the Gulf of California, and the next stop up that line, the next locked and loaded segment of that boundary, is California itself. So the question stops being about one forgettable magnitude 6, and starts being about the fault it was pointing at. Is the Earth simply going through an ordinary run of unrelated quakes that our pattern-hungry minds are stringing together? Or is a wave of stress genuinely creeping toward the most dangerous fault in America? To answer that, we have to look at just how overdue California really is. California has a memory problem, and it is the dangerous kind. The last time the southern San Andreas produced a truly great earthquake was in 1857, the Fort T. John quake, a magnitude 7.9 that ripped along more than 200 miles of fault. The northern San Andreas had its turn in 1906. The Great San Francisco earthquake, another magnitude 7.9, the one that burned the city to the ground and wrote itself into every textbook. And before those, going back to the early 1800s, there were the great quakes of 1812. Notice the spacing. The big ones on this system come generations apart, and the clock on the southern stretch has now been running, quietly, without a major release, for well over a century and a half. That is not reassuring. That is a fault storing interest on a debt it has not paid. The strain has been measured, and the numbers are sobering. Modern instruments track how the crust is deforming as the plates grind past each other, and one line of research points to the strain accumulated on these California faults being about as high as it has been in roughly 1,000 years. Sit with that. 1,000 years of comparison, and we are near the top of it. What that high strain means, in practical terms, is that the fault is closer to its breaking point than it has been in a very long time, which lowers the bar for what it takes to set it off. A fault sitting comfortably in the middle of its cycle can shrug off a nudge that a fault straining near its limit cannot. And the more loaded the fault, the more a relatively small disturbance, a distant quake sending its energy through the crust, a segment slipping to the south, can become the final straw. This is exactly why that forgettable magnitude 6 in Baja is not so forgettable after all. And there is a historical parallel that makes it downright uncomfortable. Before the great 1906 San Francisco earthquake, about a week to 10 days earlier, a large earthquake struck down in Baja California. Then, the North let go. 1 century-old data point is not destiny, and I am not going to stand here and tell you it is. But when you have a fault straining near a 1,000-year high, and you watch a magnitude 6 fire in Baja at the southern hinge, echoing the same geographic 1-2 that preceded 1906, you understand why the people who study this are sitting up straighter this week. And it is not only Baja lighting up. To the north, before Venezuela even happened, a magnitude 5.6 earthquake struck in Northern California in the hills between the towns of Willits and Ukiah, right at the bend where the fault system kinks inland. It was called historic, and not for drama, but because no earthquake that large had ever been recorded at that exact spot in our instrumental history. Farther north still, up near the Mendocino Triple Junction, where 3 tectonic plates meet, and the San Andreas hands off to the Cascadia subduction zone, another magnitude 5.5 class event, and its companions rattled the coast, as if that stretch were clearing its throat. And inland, across Nevada, in the zone geologists call the Walker Lane, swarms of earthquakes have been waking up regions that have to move whenever California strains. Silver Springs, the country around Topaz toward the Las Vegas side, all of it loosening, all of it accommodating motion. Look at a map with all of it plotted, and you see the entire western edge of North America stirring at once, from Baja in the south to the Triple Junction in the north. None of these smaller quakes is frightening on its own, and that is exactly the point. A magnitude 5 in the hills of Northern California, a swarm out in the Nevada desert, a jolt at the Triple Junction. On any ordinary month, you would file each one away and never connect them to each other. What changes the picture is watching them switch on together, spread across 1,000 miles of the same plate boundary, in the same handful of weeks that a great disaster struck in Venezuela, and a magnitude 6 fired in Baja. Whether that clustering is a real building wave of stress, or just the ordinary background chatter of a very active boundary that our anxious minds are stitching into a single story, is a question we genuinely cannot answer yet. But it is the reason the people who study these faults for a living are not sleeping quite as easily this week as they were last month. None of this is a prediction, and I want to be careful and honest with you here, because that is the whole point of this channel. Nothing about a magnitude 6 in Baja guarantees a great earthquake in California, tomorrow, or next month, or next year. What we are doing is forecasting in the way a meteorologist forecasts. When a meteorologist sees storm clouds building on the horizon and a front moving in, They do not promise a storm, but they would be negligent to look you in the eye and say the sky is clear. That is where California is right now. The clouds are on the horizon, they are drifting our way, and they could still veer off at the last moment, and we all hope they do. But the conditions, the 1,000-year strain, the northward march of activity from Venezuela to Baja, the awakening of the Walker Lane, and the triple junction, all of it lined up together, mean that the risk is as elevated as it has been in a long time. So we watch, we respect it, and we prepare, without panicking. Which brings us to the question underneath the question, the one this entire investigation has been circling. Could the sun, in the middle of its tantrum, have anything to do with the Earth choosing this exact week to move? This is the idea that ties our two stories together, and it is also the one where I have to walk the most careful line, because it is real science and internet fantasy tangled in the same knot. The claim, in its strongest and most responsible form, is not that the sun causes earthquakes. It is that intense solar and geomagnetic activity might, under the right conditions, act as a trigger, the final nudge that tips a fault which was already sitting right at the edge of failure. And you have to hold those two words apart in your mind for the rest of this to make sense. Cause and trigger are not the same thing. The cause of a great earthquake is a century of relentless plate motion loading strain into rock. A trigger is whatever fires the gun that was already cocked. Nobody serious is arguing. The sun builds the strain. The question is only whether it can pull the trigger. There are a few ways it might, at least in theory, and they are worth understanding. When flares and solar storms pour energy into the upper atmosphere, they charge the ionosphere, and they drive currents through the global electric circuit, the natural flow of electricity between the charged upper atmosphere and the ground. During a geomagnetic storm, the shifting magnetic field induces electric currents in the crust and, importantly, in the oceans, which are extraordinarily good conductors. These are called geomagnetically induced currents, and we know they are real because they are the same currents that can overload power grids during severe storms. The hypothesis is that these currents, flowing through already stressed rock, could subtly change the conditions on a fault, or that changes in the electric environment near rock under enormous pressure could interact with it through effects we are only beginning to study. Some researchers have even reported statistical hints that arrivals of fast solar wind streams from coronal holes line up with brief upticks in global earthquake activity, while that connection is active. We have watched those induced currents do real damage before, which is what makes them worth taking seriously in the first place. In March of 1989, a severe geomagnetic storm drove currents through the power grid in Quebec so strongly that it overwhelmed the system and collapsed the entire thing in about 90 seconds, leaving millions of people in the dark and the cold for around 9 hours. That was the sun reaching down and physically breaking a piece of our infrastructure through geomagnetically induced currents. And it is not a theory or a maybe. It actually happened. So the mechanism the solar seismic idea leans on, currents flowing through the ground during a storm, is genuinely real at the scale of power lines strung across a continent. The leap that even the responsible version of the hypothesis has to make is to ask whether those same currents, threading through solid rock instead of through copper wires, could ever nudge a fault that is already teetering on the edge. It is not a crazy question to ask. It is only a very hard one to answer, and the honest answer so far is a shrug, because the effect, if it exists at all, hides somewhere beneath the noise of everything else acting on the crust. Now here is where I put on the brakes, because intellectual honesty demands it. Those correlation studies are weak, they are contested, and for every paper that finds a hint of a signal, there is another that finds nothing at all. And the reason the mainstream is so skeptical is not a conspiracy to hide the truth. It is the same brutal arithmetic that killed the comet theory. the energy locked in the strain of a fault ready to produce a magnitude 7 is astronomically larger than any energy the sun could deposit into that fault through these mechanisms, by many, many orders of magnitude. The sun cannot supply the energy of an earthquake any more than a feather can supply the energy of an avalanche. At the very most, the feather might be the thing that lands on a slope already one snowflake from collapse. So if a solar seismic trigger exists at all, and that is a genuine if, it can only ever be that feather. It can nudge a fault that was already going to fail soon. It can never make a stable fault rupture. And we do not even need the sun to explain what we are seeing, which is the part people skip past. There is a completely conventional, well-documented mechanism for one earthquake to influence another, and it requires no solar involvement whatsoever. It is called stress transfer. When a fault slips, it changes the stress on the crust around it, raising it in some places and lowering it in others, and seismic waves rolling out from a large quake can briefly stress distant faults as they pass through. The magnitude 6 in Baja genuinely did load a little stress onto the southern end of the California system through plain, ordinary physics. The northward march from Venezuela can be discussed in terms of an anxious planet without ever invoking a sunspot. So when someone shows you the earthquake landing in the gap between two solar flares, the responsible response is not to deny that the timing is real, because it is, and it is eerie. The responsible response is to remember that a single well-timed coincidence is an anecdote, not a correlation. If you flip a coin and it lands on its edge, that is astonishing, but it does not mean coins have learned a new trick. One quake in one gap between two flares is exactly that coin on its edge. So where does that leave the grand unified theory? The comet and the flares and the storm and the quake all lock together into one chain of cause and effect. It leaves it as something more interesting than either the believers or the debunkers usually allow. The timing coincidences are genuinely real, and I will never tell you to ignore what your own eyes can see on the clock. But the proposed physical mechanisms are weak to non-existent, and the honest energy budget forbids the strong version of the story every single time. The mature position, the one this channel will always land on, is to watch the pattern with clear eyes and respect the physics at the same time. Hold the eerie timing in one hand and the ruthless arithmetic in the other, and refuse to let go of either. Because the moment you drop the physics, you are telling fairy tales, and the moment you drop the pattern, you stop paying attention, right when paying attention matters most. And speaking of patterns people cannot resist, there is one more version of this story I have to address, because it is spreading fast, and it points at a very specific date on the calendar. There is a framework circulating right now that skips the physics entirely and goes straight to the sky, and it deserves to be addressed rather than mocked, because a lot of thoughtful people find it compelling. The claim is that the planets themselves are lining up for something, and that the window to watch is July 3rd and 4th. In the days around the 4th of July, Earth, Mars, and Uranus fall into a rough alignment, and in the symbolic language of astrology, each of those bodies carries a meaning. Mars is read as energy, force, a cutting and breaking influence. Uranus is read as sudden disruption, electricity, upheaval, and it is the body astrologers most associate with earthquakes. And this alignment falls in the sign of Taurus, which represents the fixed, solid, stubborn Earth that does not want to change. Force plus sudden electrical disruption, acting on the fixed Earth, all at once. To someone already primed by everything we have discussed, that reads like a loaded signature. Layer on a Mars, Saturn, and Neptune grouping, a Jupiter and Pluto opposition, and a rare wider geometry some call a basket, and the case for July 3rd and 4th as a charged window starts to feel, to a believer, overwhelming. supporters will point out that a somewhat similar planetary grouping fell near the timing of a great magnitude 8.5 class earthquake in Kamchatka last year, and offer that as proof the method works. I understand the pull of this completely, and I am not here to sneer at anyone who feels it. But I owe you the physics, and the physics is not kind to it. The gravitational tug of the planets on the Earth is real, but it is almost incomprehensibly tiny. The tides that actually flex the solid Earth are dominated overwhelmingly by the Moon and the Sun, the only two bodies close enough or massive enough to matter, and even those move the ground by a small amount. The other planets, spread across hundreds of millions of miles of space, contribute a pull measured in fractions of a millimeter, a force so small it vanishes beneath the noise of everything else acting on a fault. There is no known physical mechanism by which a symbolic alignment of Mars and Uranus reaches across the solar system and unlocks the San Andreas. And the Kamchatka example runs into the oldest trap in pattern seeking, which is hindsight. If you scan enough alignments against enough earthquakes over enough years, you will always find some that line up. And the human mind lovingly remembers those and quietly forgets the hundreds of alignments that came and went with nothing underneath them. Picking the one hit and ignoring the many misses is not evidence. It is the way we fool ourselves. So I will hold the planetary alignment exactly where it belongs. It is the culturally resonant, ancient version of the very same impulse that this whole video is about. The profound human need to believe that when the sky is busy, the earth must be listening, that these events must be connected because it feels unbearable for them to be random. That impulse is beautiful, and it is worth honoring as a piece of how we make meaning. But it is not a forecast. The date on the calendar that actually matters is not written in the planets. It is written in a single enormous sunspot that, as of this moment, still has not fired. Let me take you back to that giant sunspot, because everything we have walked through tonight funnels down to it. Remember the setup. The X flare that blacked out North America came from the smaller of the two dangerous regions facing Earth. The larger one, more than twice its size, carrying the same violently tangled magnetic field, sitting almost perfectly at the center of the sun's disk and aimed straight at us, has stayed quiet. It has spent this entire episode producing those broad, sprawling loops of magnetic field, arcing high and reaching across its surroundings, the visual signature of a region holding its breath. It has not spent its energy. It has been hoarding it. And a Delta-class region, that large, that centered, that loaded, does not usually stay quiet forever. If it lets go, the consequences scale with everything it has stored. We are not talking about another X1. A region like this has the raw capacity to produce a flare of X5 or greater, several times more powerful than the one that already knocked out radio across a continent, or a long-duration eruption that hurls a massive cloud of solar plasma, a coronal mass ejection, directly down the line at Earth. And here is the timing that should focus your attention. We are not calm right now. The sun already landed a coronal mass ejection on us in this same window, a slow but dense cloud that pushed our planet into a minor geomagnetic storm, with the disturbance index reaching the G1 level as the magnetic field of the storm connected with ours. Forecasters are already carrying a watch for a stronger G2 level storm on July 3rd, with the cloud thrown off by that X-flare expected to arrive around July 3rd into the 4th. So the ionosphere is already charged. The magnetic field is already ringing. The aurora is already being pushed farther south than usual. And into that primed, humming environment, the biggest gun on the sun is still sitting cocked on the 4th of July weekend, pointed straight at us. It helps to understand what that incoming cloud actually is and what it can do. A coronal mass ejection is not light, and it is not a burst of radiation. It is a physical cloud of billions of tons of magnetized solar plasma, blown clean off the sun and sailing across the 93 million miles to Earth over a day or two. When one arrives, it slams into our planet's magnetic field, and if its own magnetic field happens to be oriented the right way, it pours energy into our magnetosphere and sets off a geomagnetic storm. That is the process that pushes the aurora, the northern lights, down out of the Arctic and lets people at the latitude of New York, or across the northern tier of states who almost never see it, suddenly watch the sky ripple with green and red. The minor storm already in progress has been doing exactly that on a small scale, and the stronger one forecast to arrive over the 4th of July weekend could push those lights farther south still. So there is a genuine chance that on a night when much of the country is already looking up for fireworks, the sky over the northern states quietly puts on a second show that no city planned and no permit approved. It is beautiful, and it is also the visible fingerprint of the very same forces we have spent this entire hour trying to understand. I want to be clear-eyed about what that does and does not mean, because I promised you honesty, and I am not going to trade it for a scarier ending. A major flare from that region would not end the world. Even a strong geomagnetic storm in the range we are actually discussing mostly means radio blackouts, satellite headaches, grid operators watching their instruments closely, and auroras dancing over places that rarely see them. It is not a civilization-ending Carrington event, the Great Storm of 1859 that set telegraph lines on fire, and I am not going to pretend it is. What makes this moment worth an hour of your attention is not certain catastrophe. It is the convergence. It is the fact that all of these threads, the flares, the charged sky, the incoming storm, the earthquake in the gap, the fault straining toward its limit, the marching activity up the spine of the Americas, are all live at the same time, and that the one variable capable of raising the stakes on every other thread, that silent giant on the sun, has not yet moved. And that convergence is exactly why the coincidence versus connection question stops being an abstract debate this week and becomes something closer to a live experiment. For most of this video, I have argued the skeptical case, and I stand by every word of it. The comet almost certainly did not trigger the flares. The sun almost certainly did not cause the earthquake. The planets are not reaching across the void to unlock the San Andreas. The energy budgets forbid the strong versions. The correlations are weak, and ordinary physics explains what we see. That is the honest science, and I will not walk it back. But honesty cuts both ways, and it also requires me to admit that we are about to watch the tape play forward in real time. If that giant region fires a major flare in the next few days, and the days that follow bring a great earthquake to a fault we already know is straining near its limit, the believers will have their moment, and the skeptics, myself included, will have to sit with a coincidence uncomfortable enough to test our own certainty. And if the sun quiets and the faults hold, and the 4th of July passes with nothing more than fireworks and auroras, then we will have watched a very loud week on Earth and sky turn out to be exactly what the physics says it usually is. Noise that our pattern-hungry minds desperately wanted to turn into a signal. Either way, the thing I keep coming back to is not fear. It is the strange gift of getting to watch it at all. For almost the entire span of human history, our ancestors lived through weeks exactly like this one. A blacked-out sky, a shaking ground, a comet falling into the sun, and they had no instruments, no data, no way to know whether the heavens and the earth were speaking to each other or simply happening to move at the same time. They could only look up and feel small and tell stories to make the coincidence bearable. We are the first people who can actually measure it. We can time the flare to the second, weigh the comet, map the strain on the fault, and calculate exactly how much the planets do and do not pull on us. And what we find, again and again, is that the universe is not sending us a message. It is just being enormous and indifferent and busy all at once, and we happen to be awake for it. So watch the sun this week. Watch that quiet giant. Not because the end is coming, but because you are alive at the one moment in all of history when you get to know the difference between an omen and a coincidence, and to look a blacked out sky in the face and understand, at last, what you are actually seeing.